Hey guys, Mrs. Traver here. We're going to walk through, We're going to walk through factoring polynomials with greatest common factor. Before we look at factoring polynomials, any polynomial, we're talking linear, quadratic, quartic, quintic, cubic. Sorry, I missed that one. No offense to you, cubic. So before we look at factoring any polynomial, we're going to first remind ourselves of factoring quadratics. And when we did this, we had problems that looked something like this. Where we were in the format ax squared plus bx plus c. And we had two methods. We could either factor with Lizzie method or factor with grouping method. And as a reminder, Lizzie method, while it was quick, it only works for quadratics. So that is a bit of a downfall there. As we're moving past quadratics into the rest of the world of polynomials, we no longer can use Lizzie. Grouping, though, works for all. So that's what we're going to be spending our time looking at, especially in this section. Our game plan here is to look at something that is a polynomial that has something that gets factored out with a greatest common factor, and it turns into a quadratic that we can then factor with grouping method, or maybe it's already factored. So let's remind ourselves of what goes on when factoring a regular old quadratic. So our first step here is to look at all the factors of a, c, which in this case are 2 times negative 5, so negative 10. And our factors here, I could make a negative 10 by using a 1 and a 10, or a 2 and a 5. And because it's negative, one of the two of these was negative. So I have this pair, and I also have this pair for each. Now, looking back at our problem, I want these to add to 9. So the only one that adds to 9 is the very first one, actually. So we'll use that in place of 9x. So how we'll write it is we'll have 2x squared, and instead of 9x, we'll have negative 1x plus 10x. You can see that those equal out. From there, we'll look at grouping. That's what this method is all about. So this is the one we're playing with. We'll group the first two together and then the second two. So with the first two, our greatest common factor, let's look at the 2 and the 1. The only thing we can pull out is an x, because there's nothing with the 2 and the 1 that we can play with, but each of these have at least one x. So I'll pull that out. And on the inside, I'd be left with, let's divide and see, x times what is 2x squared. I need a 2 and another x. X times what is negative x. I just need the negative 1. With my second group, 10 and 5, I can pull out a positive 5. And 5 times what is 10x? I need a 2x. And 5 times what is negative 5? I need a negative 1. Let me draw a line here so it's a little bit more easy to see. So from here, our game plan always is to notice that what's in the parentheses matches. So these are going to end up being the first piece of it, 2x minus 1. And what's left outside is the other piece, x plus 5. And there we go. There is a factoring problem from quadratics back in chapter 1. Moving on in chapter 2 now, we're looking at all polynomials though. So here's our next example. All right, here's one that looks like the cubics that we've seen before when graphing. So what we're going to do here is look for something that's in common with all three terms. You zoom in for us a little bit. There we go. So we're looking for something in common with all three terms. Looking first at our coefficients, we've got coefficients of 1, 2, and 15. So nothing in common there. With our x's, we've got degrees 3, 2, and 1. So the smallest degree that's in all of them is degree 1. That's what we'll pull out. So x to the first will come out. On the inside, we'll be left with x times what is x cubed? I need an x squared. X times what is 2x squared? I need a 2x. And x times what is negative 15x? I need a negative 15. From here, what's on the inside of this parentheses is a quadratic that we can factor just like we did above. So we'll go ahead and do that. First off, notice a and c are negative 15 when we multiply. So we're looking for factors of negative 15, which are 1 and 15, or 3 and 5. A combo of which that we can use to make this negative 15 that also adds to positive 2 will need to be -3 and +5. So there's the combo that we need. And let's replace what we have in here. So we'll replace our 2x with a -3x and a 5x. So let's make sure we have this x still hanging out up front. And then on the inside, we've got x squared minus 3x plus 5x minus 15. All right, grouping method says then next to look at the first piece of two terms and then the second piece of two terms separately. So let's do that. I'm going to make sure I leave this x hanging out with me the whole time. So be a little careful there. My first two terms, what's in common? Let's see, I've got a 1 and a 3. No greatest common factor there. And then I've got degree 2 and degree 1. So I can pull out at least degree 1. So x to the first. What's left on the inside, I've got x times what is x squared? I need another x. And x times what is 3x? So I need a -3. With my next two terms, 5x minus 15, the 5 and the 15 both have a 5 in common. So let's pull out a +5. And what will be left on the inside is, let's see, 5 times what is x? I need a 5. I need an x to make a 5x. And 5 times what is -15? I need a -3. And then I'll throw that last parentheses in there for our leading x. So let's see, just like we did above, we've got our x minus 3 and our x plus 5. And we can drop down our first x that we've had all along. The most common mistake I see is that you work through this okay, but you just like lose this x. That was the very first thing we did. Don't lose it. Just keep it on the outside the whole time. So there we go. There's the first example. Let's look at example 2. All right, let's look at this one. It's going to be a little nicer. So we've got, first off, with the numbers 2 and 18, there's a 2 in common. And x to the 5th and x to the 3rd in common, I have at least x to the 3rd in both of them. What's left on the inside? 2x cubed times what is 2x to the 5th? I'd need just an x squared. And 2x cubed times what is -18x cubed? I need a -9, and I have all the x's I'd need. Where we're at now, we've got one of these special cases where I do have a quadratic that's left that I can factor. It's kind of a weird one though, because I want it to add to 0. So my a and my c here are multiplied to get -9, which is a 1 and a 9 or a 3 and a 3. And I need them to add up so that my b term is non-existent, which means I need a +3 and a -3, because that will make a combo for me that is 0. So we'll do that. We've got x plus 3, x minus 3, and out front we still have 2x cubed. So this one's kind of nice because it's in that difference of squares situation. So that was a rule there. If you remember, this is x squared minus 3 squared, and then this was a setup that always worked for those. So let's do another. All right, our next one here, example 3, is 27x to the 5th minus 45x to the 4th plus 18x cubed. What we'll look for first is just our coefficients, 27, 45, and 18. Hopefully we got our math facts down. I noticed there's a 9 in common with all three of those. We can pull a 9 out. Further than that, I've got degree 5, 4, and 3, the smallest of which being 3. So I can pull out a 9x cubed. On the inside, I'll be left with, let's see, 9x squared times what is 27x to the 5th? Well, from 9 to 27, I need a 3. And from x cubed to x to the 5th, I need an x squared. From 9 to -45, I need a -5. From x cubed to x to the 4th, I just need an x. From 9 to 18, I need a +2. And from x cubed to x cubed, I don't need anything else. What's left in our parentheses is a quadratic that we can factor. So let's do that. Looking at a times c, we've got 6, which is made by a 1 and a 6, or a 2 and a 3. And it's a +6, so either it can be made by a positive or a negative. Since our middle term is negative, I know that these would both have to be negative, and the combo that works for me is -2, -3. So let's trade those out here. All right, so a little bit of copying. And then instead of negative 5x, I'll put negative 2x, negative 3x. Dropping down around. It is really important here. Let me just pause and make a comment about lining things up and being organized about your work. It's really important that you're dropping things down in the right places, on the left and the right. So this 9x cubed needs to drop in the same spot, as does this 2 has to drop. And it can't really get shifted too much, otherwise our grouping isn't going to work. So just everything has a place, leave it in its place, and that's what I have to say about that. So let's carry on with our grouping. Our first piece is here, and our second there. So let's see. We've got a 3 and a 2. Nothing to pull out there, but I do have an x squared and an x, so I can pull an x out of these terms. And I'd be left with x times what is 3x squared? I need a 3 and another x. And to go from x to negative 2x, I need a negative 2. Negative 3x plus 2. The 3 and the 2, there's nothing in common with, and there's not even x in both of them. So when you're in this weird situation, we want to pull out a 1 or a negative 1. Let's think about it for a minute. If I pull out a 1, a positive 1, then I'd be left with negative 3x plus 2 in parentheses, which doesn't match my other parentheses. If I pull out a negative 1, it'll give me a positive 3x minus 2, which is a match. So that's what I'll need to do. If there's no GCF, pull out a 1 or a negative 1. Just make sure they match appropriately. Be careful. I almost forgot to drop down my 9x cubed. So I'll do that and throw parentheses around the whole thing. All right, almost done. So let's see. We'll leave this 9x cubed out front. And then I have 2 parentheses to put with it. One of them is our 3x minus 2. And the other is our x minus 1. And all set on that one. All right, here's example for the last one. Let's see, between 24 and 6, what can be pulled out? I can factor 6 out there, and I've got x cubed and x to the first, so I can pull out at least a factor of x. Left on the inside, I've got 4x squared plus 1. From here, this quadratic is, again, kind of like example 2. I just want to throw another one in there so you're aware of them. So we've got this 0x on the inside here that we're kind of imagining in place. If you would like to write this step out, I didn't on the last one, but on second thought, it might be nice to see. So there's no x term, therefore there's 0 x's, but this still is a quadratic that we can factor. Looking at A and C, we've got 4. Which is made by a 1 and a 4, or a 2 and a 2. And it's a positive 4, so they're both positive or both negative. I'm sorry, actually going back, this should have been a negative 1 here. That was my mistake, going a bit fast. So there we go, it's a negative. So either one's positive, one's negative. And I need this combo in order to make a 0 when you add. So we'll put that in place of our 0x. So we've got 6x times the quantity 4x squared. And instead of 0x, I'll put minus 2x plus 2x. And then drop down on minus 1. Grouping the first 2 separate than the second 2. So for my first 2, I've got a 2 in common and an x in common. So I can pull out a 2x. 2x times what is 4x squared? I need another 2x. And 2x times what is negative 2x? I need a negative 1. My second piece, 2 and a 1, nothing in common, x and no x at all, nothing in common again, so just plus 1, and on the inside I'm left with 2x minus 1. Don't forget about your 6x, leave him all the way on the outside out front. Now, let's see, we've got our 6x, we've got our 2x minus 1 that was in common, and we've got our 2x plus 1 on the outsides. So there we go. That is as weird as it gets. You're going to do some practice now. Hopefully this video worked out for you guys. It was my first shot at throwing in the questions throughout, so hopefully it worked out for you. And then we will talk about this tomorrow. See you then.